experience our own version of this unique time of life for us all, but would ask that everybody helps keep themselves muted unless they have questions they want to ask so that we can clearly hear our speaker. We have a little bit of announcements we'd like to kind of start today's session off with. So Stephen Harl's going to take a moment and give us a few quick announcements before we turn things over to Hari for our presentation.
Great, thanks, Brian. So I'm here representing the SIG HPC CISPRO's virtual chapter. We are having elections coming up very soon, and I'm hoping that everyone on the call saw my email to CARC systems facing. Please let me know if I go out. I just wanted to encourage everyone to apply. If you are interested. We're doing a number of different things in the chapter right now. We have a invited talk series, hopefully series at PERC. We did it last year. It was a big hit. We'll see if PERC happens this year, but we have been accepted for PERC. And then also at SC, we do the HPC CISPRO's workshop. So those are our main big products. So please, please submit your candidacy to me. All the details are in the email. Feel free to email me if you have any questions. Now, my second announcement is actually also from SIG HPC CISPRO's. We've been working with SIG HPC Education to try and formalize training and education for systems professionals. Right now, we're in our early stages, just trying to gather information and things like that. You may have seen me try to crowdsource some of that through the systems facing CARC mailing lists and others. So, but we would love, if that is of interest to you and you would like to join our committee to talk about this stuff. We're still kind of just getting formed, and we could use any help that you'd be willing to give. So please contact me or Shelley Knuth at Colorado. She is from the education side, my co-chair, and I'm from the CISPRO side. So those are my two main announcements. Are there any questions about either of those things? Well, we'll take that as a no. If you did have a question, please feel free to email me at sharrell@Purdue, or reply to my emails or whatever. Brian, thanks for giving me that time today.
Sure, thanks. As long as Stephen's here on the call, you can also send him a direct message in the Zoom chat. If you didn't get that email, he can get you some additional information so that you can get back with him later. So with that, we'd like to then turn our time over for our main topic today, which is visualize and analyze your network activities using OSU INAM, tool kind of focused around InfiniBand, or at least that's the perspective we've had as we've started to look at it. So we have Hari, and I hope I don't mess the name up, Subramoni, and from OSU, who has graciously given us some time to present on this. So Hari, if you would indicate how you'd like the group to handle questions, whether you want us to ask as we go along or hold them off. What Troy and I will do behind the scenes is kind of watch for questions to be typed in the chat and kind of just make sure you're aware of them. Let you go from here.
Thank you, Brian. Thank you all for being here. First off, am I audible? Okay. So I see Brian nodding, so I hope I'm audible. Broadly, I'd like this to be a dialogue rather than a monologue. So if you have questions, feel free to interrupt me. So broadly, the way I want to, let's say, set up this session is as follows. I have a short presentation detailing at a high level what gap in the current tools ecosystem INAM is trying to fill. And the rest of it will most probably be an interactive demo where I log on to OSC and try to show INAM running on OSC in a live fashion. And I'll walk you through the various features that INAM has. So this is how I am planning. And if you have any questions, comments, thoughts about, hey, this is bad, this is good, change it like this, things like that. Feedback is more than welcome. So if you look at, and this is a brief outline of the presentation. So I'll first try to introduce and motivate what INAM is trying to solve, the design, and of course the overhead. So one of the critical thing with any tool is the kind of overhead it has on applications as well as the entire system as a whole. And then we'll go into a demo, and finally I'll conclude. So if you look at it, current InfiniBand-based clusters and MPA-based applications are very complex. So just a footnote here, we had support for Omnipath, or we were trying to bring in support for Omnipath, but since the product is kind of end of life now, we are not actively pursuing that. Instead, we are trying to go go along the Ethernet side and trying to see if we can enable INAM for high-speed Ethernet and like the upcoming Slingshot kind of ecosystem. So sorry for the segue. So given the current complexity in the way InfiniBand-based clusters and MPA-based applications are, it is very challenging to identify the interaction between and the impact of the underlying IB network on HPC applications. So for instance, a user might come to you and say that, hey, you know, I ran my PSDNS application 3 days before on Frontera, and the performance was great. I was getting 10 seconds per iteration. I'm running it again today. I'm getting 250 seconds per iteration. What's going on? So typically, if you are a system administrator, you will have to go to each switch or each link and try to see if there is congestion coming up, if there is like blocking, if there is discards happening, things like that. And this is generally a pain, especially if your cluster is fairly large. So right now, people rely on a plethora of MPA level, IB level, cluster level debugging tools to answer this question. So you have lots of tools like Nagios, Ganglia, and a bunch of other things. But there is a lack of interaction with and knowledge about the MPA library for fabric level tools. The fabric level tools only look at the InfiniBand level counters or things like that without correlating it back to the to what the application is doing. And you also don't, these fabric level tools also don't know what jobs are running and which job is potentially causing a traffic on a given link. So in short, if you look at current day HPC clusters, you have multiple components. You have the job scheduler, you have the MPA library, you have the underlying fabric. But no tool can correlate all three components and tell you yesterday night at 10 p.m. job X was sending so much traffic on link Y through the network. And this was contending with a different job on the network, leading to slowdown. So no tool can tell you this information in a succinct fashion without the user having to correlate information from 3 or 4 different tools and jumping through a bunch of hoops. So this is exactly what the INAM tool is trying to address. Can we design a tool that enables in-depth understanding of the communication traffic on the network through tight integration with the MPA runtime and the job scheduler? So this is an overview of INAM. Again, this slide is a little old. We have released a bunch of different versions since then. So broadly, if you look at INAM, you have multiple components. You have a web-based user interface, which shows up to system administrators, MPI developers, or application scientists. You have a daemon, just one daemon. If you are using INAM, you do not have to run a daemon on every single node of your cluster. You just run a daemon on one node, preferably where OpenSM is present. And that daemon will be responsible to query the entire fabric, collect the necessary fabric information, and insert it into the database. The daemon will also query different job schedulers like Slurm or PBS and get the job level information from them. The MPI library will push information to the daemon. So you have two places where you are pulling information and one place where information is being pushed into the daemon. So the daemon pulls information from the fabric and from the job scheduler, whereas the MPI library pushes information into the daemon. Now, all of this information is pushed into a MySQL database, which is queried by a Java web server and presented to end users through a web interface. So at this, okay, there is a bunch of messages in chat. So at this point, let me stop the presentation and go to the demo, because that may be more useful and interactive for the audience members. So this demo is showing the Ohio State supercomputer clusters live right now. Are you guys able to see my screen? Yes. Okay, I assume you are. So
yes, we can see it.
Okay.
Yes, we can see.
Okay. So this is a representation of 3 different HPC clusters at the Ohio Supercomputer Center. So the bigger cluster, I believe, is Spitzer. Then you have Ruby and Owens, and you also have the IO cluster on the side. Now, this is what we call as the live network view. So this gives you a snapshot of what is happening in the entire network right now. So as you can see, the red links are like heavily used. The light green links are not so heavily used, like 5 to 25% utilization. The dark green links are like 25 to 50% utilization. And the orange links are like much more like heavily used than that. So this is like an overall view of the system. So this is kind of a logical representation. So you can try to look at the entire system, or for instance, if you want to look at a particular job ID, so you can go to what is called as the live jobs page. So this information is collected by the INAM daemon in interaction with the job scheduler. So now you can see that there are several jobs running on this cluster, but only certain jobs are pushing information to the INAM daemon. The remaining jobs are not pushing information, probably because they are using an MPI library which does not support INAM, or it is like a non-MPI job. Now, let's say if you want to see what this job is doing currently in the network. So you copy the job ID and say that, okay, this is the job I want to see, okay? And you click on load. So this is how that job looks like, okay? So as you can see, there are 2 nodes which are part of this job, node A and node B. So you have the information of what the exact nodes are, and the path the traffic from those jobs take through the network. So you can see that this job goes are on 2 nodes which are separated by multiple switch hops. Now let's say if you want to see what is happening on a particular node, let's say I have this node, let's see what happens on this node. So I can open the node information and see what exactly is happening on this particular node. So you have a high level information of the job here, and you have information about the CPU utilization at a node level granularity or a process level granularity. So there are like a bunch of processes running on this particular node, and this is the amount of CPU that each one of these processes is taking, and this is the amount of virtual memory that they are taking. So if you go down further on this job, you can see various MPI level parameters, like the amount of communication buffers being used. And you also have a bunch of node level statistics saying how much data was sent, how much data was received in an aggregate fashion, and also in the last, let's say 30 seconds. And you can look at different counters, like how much packet was sent, how much was received. Out of this, how much was collective. So if you look at it, not much, sorry. So this looks like a collective byte sent. So the reason why you don't see much here is because it takes about 30 seconds for the latest data to be fetched. So you can look at different values. For instance, you can look at the number of IO bytes read or received. So this looks at POSIX IO, and it can also look at Luster IO. So this is the entire node at a glance. So if you want to drill down further and see what a given rank is doing, you can also do that. So this is one rank on that node and the kind of communication that that particular rank is doing right now.
Hari?
Yes?
There's a question in chat from Alistair that wants to know whether or not this requires the patching of MPI.
Yes, if you want to get MPI level information, this requires the patching of MPI. So we are working to make it so that it works with what is called the MPI tools information interface. Are you guys familiar with the MPI tools information interface, MPI-T? Okay, so MPI-T is something that the MPI 4. Like MPI standard is coming up with. So they have what is called as an events-based interface where profiling tools like Tao or INAM can query the MPI library and get the necessary information. So since that is still in a nascent state of development, this work currently needs some patching inside the MPI library. But going forward, no patch will be required, and the tool can directly query the MPI library through the MPI-T events information interface and get the necessary information. Is that clear? Okay.
Yes.
Okay. So again, going down, this shows a lot of rank level information, and you also have a lot of communication grid kind of information here. So what INAM allows you to do is go all the way from, let's say, the network level, drill it down to the job level or the process level and see what exactly is happening. And you can also look at different kind of metrics. So here I'm just looking at the number of bytes sent or received. So what you can do is, for instance, from a system administrator's perspective, you might only care about error counters. So you want to see are there any receive errors happening or send errors happening. You might want to see if there is congestion in the network and if there is a transmit discard. So you can filter the view based on different kind of counters. So like VL15 drops. So there is a lot of flexibility for you to figure out what exactly happened in your entire cluster based on the kind of filters that you want to look at here.
Hari?
Yes.
Alistair asked to follow up as well.
Okay.
So back to the patching part, he said, so does that mean it will turn things from a push to a pull?
Yes, it will turn things from a push to a pull if you tell INAM what all jobs it needs to query. But that is still a work in progress, and it needs some standardization efforts from the MPI-T, so the MPI forum. But maybe in 6 months or 1 year, once the MPI-T standard is evolved, that is where we'd like to go, because then this tool can work with any profiling or any MPI library like Intel MPI, OpenMPI, or MBAPH tool. So now, for instance, if you want to see, for let's say, let's go back to this job level view, and suppose you want to see what happened on this particular link. Okay, so you can open the link information and either view the data in an absolute manner or a relative manner. So here it is absolute that we are showing. So this shows how much data that is going over the link. Now, if you want to look at it in a relative manner, you can also view that, saying like what percentage is going on here. And you can either view it at a network level or, for instance, like a job level. So if you want to view it at a job level, then it will tell you that, okay, on this particular link, you have this job which is currently communicating. And if you can even drill down further, you can go down to a process level and mention what all job IDs that you want to, and it will say that, hey, you have all of these jobs which are communicating on this link right now. And all of this gets auto-populated. Now, as you can see, this link is going from the switch to the node. So this is like ingress traffic. So what this says is that you have all of these ranks which are receiving data from the switch to the node. Now, if you scroll down, you will also see egress traffic which shows the data which is going from the node to the switch. So you will see that you have different kind of ranks which are sending data in and receiving data outside of the node. So if you want to filter this at any different levels, you can, for instance, like remove one of these ranks and ask it to like refresh the information so that those ranks will go away from this display. So from your broad network level view, you can go down to a job. In that job, you can figure out, let's say, what is going on the switch. Okay, so this is like a switch level information, and you can figure out what is going on. Let's say a switch, like a port 1 of switch A, port 2 of switch A, for the last 5 minutes, or maybe for the last 1 hour. So all of this information will get fetched in a live fashion from the database by INAM. So this has been running on the OSU cluster for quite a while now. So you have all different kind of information that you can get here. So let's say going back to the network view. So it takes a couple of seconds to load up. You can also have like a historical view. So if you want to figure out what happened in the last 10 minutes, you can ask INAM to render that, and it is going to fetch the information from the database, and it will kind of play what happened in the last 10 minutes for you, as you can see here. So this is information that is being fetched from the database, and it is displaying how your network traffic changed in the last 10 minutes. So if you want to, you can figure out what happened X number of days before based on whatever data retention policy that you have enabled for your cluster. So this is another feature that INAM has. So you can have either a live view or let's say like a network level view. So again, going back to the live view, this is what happens. Now, if you don't care about links which are, let's say, not at all used, you can cut them off from your view. And let's say I only care about links which are like very, very heavily used. So then I can just take a look at them and see what's going on here. I can zoom in, zoom out, and do all different kind of activities, and say that I only care about links which are quite heavily used on this. So I can open up any like link information and figure out what's going on that given link at a given point in time, and how much data is being sent, and so on and so forth. So all of these things can be figured out from the live network level view. So going back, so the you have a lot of debugging information as well. So for instance, you have a page here for debugging, which tells you currently what is happening. So how much time has INAM been up? What else is what is the configuration that is being used by INAM right now? So when you start up INAM, you mention all different kind of configurations, like what is your MySQL database, what is your password, what is your data retention policy. I want to retain data for the last maybe 2 days, 3 days, 5 days, 7 days. I want to query the network once every second, once every 30 seconds, once every 10 minutes. So all of these policies can be set in the configuration file when you start up INAM, and this would show you all of those policies here. So another thing that you have in the live jobs page is the ability to order jobs based on, like, let's say CPU usage, virtual memory usage, total IO that is happening, total communication. Out of that communication, how much is intranode, how much is internode, and a bunch of other like parameters that you see here. And you have information about all jobs which are happening on the cluster right now. So, okay, before I go further, do you guys have any questions, thoughts, comments on this? do you guys think it is useful? So as I mentioned, I can keep talking about this for an hour or two without stopping, but I'd rather this be more of a dialogue. And if you guys have any feedback, I'll be extremely happy to listen to it.
So Jeremy just typed into the chat a question if there is an API to get this information, or do we have to go through the web interface?
So right now you have to go through the web interface, but we are working on like a alert kind of a mechanism where the INAM tool will send out an email alert to like a system administrator saying that link X on the network crossed 75% utilization, or you are getting port transmit discard or port transmit wait on your network. So we are trying to come up with an alert based scheme so that the user does not have to go through the web interface. So do you guys think that a command line kind of interface is a more useful for system administrators, or a web based interface?
So it looks very useful. It feels like, I guess so far you've given us a lot of insight on how a user or a user services person might look at this to help a user understand their particular job.
Mm-hmm.
Do you mind spending, and you did just touch on the alerting part. Do you mind spending a little bit more time how you see the system admin, who's watching over the fabric, or the network admin watching over the fabric, beyond just the live view?
Mm-hmm.
What are they going to be able to use this for to kind of approach monitoring and maintaining the fabric, especially for those hours that they're not watching it, where they can't just use the real-time view?
So that is where the alert system will hopefully come in. So what the alert system is meant to do is exactly this. So during the night time, or ideally we don't want the system administrator to be looking at this 24/7. Instead, it'll be helpful if they look at it when particular events of interest that they have defined occur. So with the next release, what we are trying to do is to create user-defined alerts. So for instance, if a job is using like a lot of communication or is pushing a lot of communication, or if a particular link is generating, or if a particular port is generating like port transmit discard or port transmit wait counters, which is indicative of congestion in the network, we would send an alert to the user so that now, or the administrator, so that the administrator can then go ahead, look at that particular port, and then try to figure out what jobs are using that link, and try to trace back the job, and maybe check with the user of that job saying, hey, what happened? So instead of reactively trying to figure out what happened, we hope that INAM will allow the system administrators to be proactive and reach out to the users and say that, hey, your job is causing a lot of congestion in the network. Can you tell me what's happening? Or your job is pumping a lot of IO, like cluster IO or POSIX IO into the file system. Can you tell me what's going on? So the goal is to proactively find out these issues before they cause problems for other users as well. Does it make sense?
Yes. So I guess then maybe reaching beyond where you're at right now with the alerts, if we get an alert, do you envision then or know whether or not we'll be able to take that content of that alert and then kind of go back to kind of look at what the world was doing at that point? Maybe we have a link called out in that alert, but maybe the question now is what was using that link? So I guess in my mind, I'm kind of seeing this kind of, is there a way to then kind of go back to the historical view to kind of see what was traversing that link at that time?
Yes.
Just to kind of try to understand what the other players were beyond just the link.
Yes, so we have a historical view for the link information as well. Excuse me. So, so once you go to the historical view and click on a particular link, you can try to figure out what was happening on that link at that point in time. So all of this information has been stored in the database. So you can figure out what exactly was happening on that link. So just like you see this right now, you can have a historical view for the link and say that, hey, I want to figure out what happened on this link from yesterday night 11 p.m. to like 12 a.m. So yes, that is possible. So once you get an alert, you will probably get an alert saying that Portex was generating this. Now you can figure out which link Portex was connected to. Click on the link and try to pull out historical information and try to see which job was, let's say, contributing to data there. The other way you can do it is, let's say if you click on a link, so let's say if you click link, you can try to find routes specified. Let's say, so you can select this node, and let's say you can try to find out the links. Okay, it's taking a bit of time. So you have this feature which allows you to figure out what routes are going through this link. It's taking a bit of time to show up, but with that feature, you should be able to figure out who all was contributing data through this link. Is that does that help?
Yes, thank you.
Yeah. Any other thoughts, questions, comments, things that you would like to see? So either this has been very boring, or I've made a fantastic job of presenting this that you have no questions whatsoever.
No, it's been good. So from the alerting standpoint, would we then also expect some kind of web integration with that, where I could come in here and maybe find a tab that takes me to the last alerts? Yes. Not only did I get them via email, but I can come in here and wade through them in that fashion once it's there.
Yes, yes, yes. So that's definitely in the works. That's a very good feedback. Thank you for that. Yes, that is what we are envisioning. So like just like this debug tab, we'll have an alerts tab here where the users can scroll through all the alerts that showed up in the last like day, 2 days, whatever as defined by the user, so that they can let's say maybe come in the morning and see what all happened.
So Jeremy typed a question. He's asking about delegated administration ability, either read versus read write or something more granular. And I'm going to add a little bit to that, because while we've been playing with it, I've been playing with it on older hardware. And so the disks are not the best. The memory wasn't the best. So I knew we were pushing it. So part of what I think Jeremy's asking, it may not capture everything, but how do we keep, if we let users get to this interface, how do we keep them from tanking it?
So what we assume is that you can have different kind of views. We don't envision, again, there are concerns about security and privacy that also might come into play. So what sort of a view should be given to a regular user of an HPC system versus what sort of view should be given to the system administrator? A regular user may not be given the full network view or the ability to access what other users are doing. Whereas a system administrator may be given the full network view. So that is something that we are still working on. So our assumption is that at most 2 to 3 system administrators will be using the full network view, and your regular users, based on whatever Munge or Apache based authentication you have, will have a subset view, and as a result will not create so much of a load on your Java web server or your INAM daemon, and thus not tank it. Does it make sense?
Yes, but that granularity is still coming, not here yet, right?
Yes, yes.
Okay, so right now, I guess our approach, and I guess I'm asking, does this kind of fit what your current vision is with the current version, is that instead of letting my user have access to this, my user services people have access to this, and then they would partner with the end user to let them see what they need to do, and that would kind of be the gatekeeper for the moment.
Yes, yes. That is what we are envisioning as of now. So that your system administrator is probably going to be the person who's going to use it.
Okay, so there's 2 other questions that we're throwing out here.
Yeah.
Alistair's asking, what sort of data size do you generate daily, hourly, and what is the overhead on the nodes?
So if you go to, so the amount of data size that is being generated depends on like several factors, like your system size, your job size, how how many nodes are there, how many switches are there, so on and so forth. So we have a useful thing called a database size calculator. So if you go to the INAM website, eventually, yes, and if you go to the bottom of the INAM website, you have this database size calculator where you can enter like different parameters like the number of switch ports, the interval at which you want to purge information from the database, for how many days you want to retain data. Do you want to query the ports on the nodes themselves, or do you just want to query the switches? So based on this, the database size calculator will tell you, let's say, let me put some number. Let's say I have 1,000 ports, purge interval of maybe, let's say, 48 hours. And let's forget about this for now. And what else is required? So it says that this is the estimated DB size. So if you increase the number of switch ports to maybe 10,000, then your DB size keeps on increasing. So based on the individual parameters for your system, you can try to enter the data here, and this will tell you up to what size your database can grow. Is that clear? Okay. So the other question was from Anita. So I think the question from her was, can you discuss the impact of MPI patching? So we primarily support OpenMPI and other versions of MPI like MPatch. So what I assume is that the impact of patching the MPI on the performance of end applications. Is that right? So, okay. So far, like we have a couple of publications studying exactly that. And what we see is that there is less than 5% overhead on the performance of your end application. So if you're running a communication intensive application like a all-to-all benchmark or like a micro benchmark, even at that level where communication is extremely dense, we see less than 5% overhead on the overall execution time of the application. Does that answer your question? And I can point you to some publications which studies things in more detail. So we have run benchmarks like your NAS benchmarks, IMB, OSU micro benchmarks, and we have studied the amount of impact the MPI-based data collection has on the overall execution time of the application. Okay, so there's a question from Martin. So what involves the MPI patching? So right now, basically the MPI patching is just we have a small piece of code in there which sends out information periodically to the INAM daemon. This is a very small self-contained piece of code. We are trying to extract that out as a shared library which can be linked as an .so file, or it can be preloaded, and it will send information periodically from the MPI library to the INAM daemon. So right now this patch does not exist for other MPI distros, but we are trying to pull that out and make it available to users so that if you are using MPatch or OpenMPI, then what this will do is to query all the performance variables which are defined as part of the MPI-T interface and send it out to the INAM daemon. So yes, Anita, that is the correct site to review. Any other questions? So if so, I can mention something briefly about future work. So currently, as you can see, most of the work is centered around the network level, the internode network, but most of the computing systems which are being deployed right now are extremely fat nodes with GPUs on them. You have GPUs, you have NVLinks connecting with GPUs, you have all sorts of complex intranode topologies coming up as well. So one of the things that we are trying to do as part of future work is to enable profiling GPU to GPU communication and trying to see and profile and visualize what happens when somebody is running a DB or somebody is running an application on like a GPU. So how much data is being transferred from the GPU to the CPU, from the GPU directly to the network, and what sort of links are being used? Is data going over NVLink? Which NVLink is the data going over? Are we sending data to the PCI? Is there intranode contention happening? All those kind of metrics is what we are trying to do next. So what we envision is that in the future, when you open up any of this node and look at node information, you would see something at the top with a description of the intranode topology and showing how processes are communicating within that one node. So this is, excuse me, one of the future works that we are thinking of. Any other questions, thoughts, comments, things that can be done, things that you would like to see?
So kind of back to the database calculator kind of direction.
Sure.
You've got clearly a fabric here that's very large, especially with the different lobes that you're showing on there. This kind of then relates to some of the emails I've had with you guys as we've been playing with it here.
Mm-hmm.
You give the calculator for the INAM configuration for the database,
mm-hmm.
but I think it would be nice to see a reference to some hardware that you guys are running it on, CPUs, storage devices, just to kind of help us get a better idea of what type of hardware beyond just the capacity of the database that we should be planning to throw at this to get good performance out of it.
Sure, definitely. That's a very good comment. And for, just so that you know, this is running on a Haswell node on OSC. I think it is a 24-core Haswell node with a regular hard disk. It does not have SSDs or anything like that. So as long as the node is not like too old, any compute node which is like any server class compute node which is like less than 2 to 3 years old should suffice to run INAM. So if you are using let's say like a Westmere node which is 8 cores and like already maybe a decade old, probably that will not be able to service a cluster which is about, this is OSC, about 2000 odd nodes. And yes, we will update the website and the user guide with this information.
Do you know what kind of memory footprint your Haswell node has?
So it has, I think, 16 gigs of, I know, no, not 16 gigs. I need to check. Kamal or Puya, do you know how much memory the Haswell node has? Does it have like 64 gigs or 96 gigs?
I think it's 96 gigabytes.
Yeah, it has 96 gigs of memory. So there have been like 3 questions. So the first one is from Anita. So the question is based on the comments, it seems this tool is more appropriate for support or system staff versus clients on the cluster. So currently, yes, this is more appropriate for system staff. But one of the things that we want to do going forward is to enable observability and interpretability for end users. So we work with a lot of users who run applications at scale. And we get this question always saying that, can you tell me what is going on in my application right now? It seems to be hanging for 10 minutes or 15 minutes without anything to do. So what we want to do for these users is to show the communication progress inside the MPI library by tracking various request objects. So what we envision is something like this. If you open up, let's say, a node or a job, we can try to tell you that, okay, this job is currently doing an all-to-all, and this all-to-all has maybe 1,000 steps. Out of the 1,000 steps, you are currently at step number 500, so that they know what exactly is happening, so that you get more visibility and observability into what is happening with your application at real time with low overhead. So going forward, we want to make this tool to be useful for end application scientists as well, so that they can be more cognizant of what is happening with your application right now. This is particularly true for large and like reasonably long-running applications. Is that clear, Anita? Okay. So the next question is from Paulo. So developers tool, anyone can use it. So, so the question is that there are multiple questions. Can anyone use it? Yes, of course. It is free for download from our website. The website was pinged in chat by Anita a couple of minutes before. I can also like message it out here. It is free. Anybody can use it, just like Brian is using it, and folks at Utah and Georgia Tech are using it. Feel free to use it. If you have comments, if you have feedback, please let us know, and we can try to work with you to make it better. The second question is, does it interface with GPFS? Not right now. So we are trying to work with the OSU folks and bring in support for GPFS. Right now, it supports Lustre and your POSIX IO. We are working towards making it support GPFS as well. So the next question is from Adam. So storage requirements NVMe. So in order to run the INAM daemon, at least on the OSC cluster, it is your standard hard disk drive. There is no NVMe, there is no SSD, there is no fancy high-end storage. Of course, if you have high-end storage, definitely throw your high-end storage at it. You will get much better performance. But for a cluster of the size of OSC, your regular like 7200 RPM hard disk drive seems to be just fine.
So let me maybe ask a little refinement on that. From the ingest, from the collection of the data, what I have observed on our setup, that agrees very much with that. But I guess the direction I've wondered is, if I get one or more users into the web interface, especially if they're playing with the historical view, does that answer change?
Yes, it does change. So it definitely does change based on the load that you put on it. So for instance, if you are querying historical information for 10 minutes, not a big deal. But if you are querying historical information for 2 hours or 3 hours for a cluster the size of OSC, then that is a lot of data that you are getting from your MySQL database. So then if multiple people are trying to do it, it will put some load on the like the hard disk. And at that point, yes, I would recommend going to a higher end storage device. So it completely depends on your usage. If you have higher performing IO devices, then definitely throw them at INAM. But again, it depends on your usage characteristics. Does that answer the question?
Yes, thank you.
Okay. So there is a question from David. MySQL tends to be low on parallelism, often single-threaded. So core count is usually less important than core speed. RAM is usually the most important thing, faster disk, flash, not necessarily NVMe. So this is, we agree on this. So MySQL has some optimizations to store data in like RAM-based file system on the front end. We are using that. And as Puya mentioned in chat, we are also trying to explore other storage options like Cassandra, like NoSQL options like Cassandra, and other memory-based databases like Memcached to see if the performance can be improved further. But the reason why we went with MySQL is because of the ubiquitous nature of MySQL and because of the availability of it. But again, the IO component of it is definitely a challenge which we have to address, especially if you want to query extremely large clusters like Frontera, which has like 8,000 nodes at maybe like 10 or less than 10 seconds granularity. So IO becomes a big challenge as your cluster size scales. Any other comments, thoughts, questions? So one of the other things that we are trying to do is we are trying to work with the Redfish interface to Redfish or basically the IPMI interface, so that we can get more of system health metrics like what is the temperature, what is the power consumption of the node, and things like that. So that is one of the things that we want to add in one of the future versions of INAM. Now, another interesting thing that we have is support for like a sandbox mode of operation. So suppose you're interested in INAM, but you are a little hesitant about deploying it on your entire cluster. and you want to understand how INAM would behave for your cluster without actually having to deploy it on the entire system. So we have what is called as an emulation mode, where you can provide the output of IB net discover, which is basically the entire fabric dump, to INAM. And you can tell INAM that I want to run jobs between size 2 nodes and 10 nodes or 100 nodes on this cluster, and simulate how INAM would behave like for this cluster, so that you can run the entire thing on one individual node without affecting anything on the cluster, so that you can evaluate how many clients you can handle at the same time, what is the IO requirements, how does the size of the database grow, how is my rendering happening, and things like that. So you have this emulation mode that we are working on, and it should be available with the next release, which allows you to use a sandbox kind of an approach to running INAM. So I'm hoping that this would be more useful to people who are a little hesitant to deploy a tool like this on the entire cluster in the first go, and instead want to try out the tool in a sandbox kind of environment. Any other thoughts, questions, comments, things that you would like to see, things that we are not addressing enough? So let me just see if there are any other questions that I had missed.
So I guess I had one question. I'm not much of a web person, but when you're setting this up, you get the choice of using the internal rendering or the Phantom.js.
Yes.
When I was talking with a couple coworkers here, people were noting that Phantom.js isn't being maintained anymore. Do you guys have a vision beyond Phantom.js at this point, or do you just plan to stay with Phantom.js?
So the only reason why we went for Phantom.js is because we wanted a representation like this. So one of the feedback that we got from other system administrators was that they would like to have like a cluster level view. So this is currently not exactly like your physical layout. Your physical layout is like a bunch of racks with a top of rack switch, from there going to a spine switch. So the reason why we brought out Phantom.js was because we wanted an interesting rendering like this. So this rendering is created by a JavaScript called vis.js, which uses a lot of physics-based modeling to create this. That physics-based modeling takes a lot of time to render. So for a large system like Frontera, the first rendering would take maybe an hour or an hour and a half. But we don't want that to happen. We would like the website to render very quickly. So what Phantom.js does is to basically cache that information. But if you don't want like a display like this, and instead would be okay with a rack level display, which is as it is in real life, then the Phantom.js dependency would not be there at all, because it'll be very easy to render it in a rack kind of organization. But if you do want this, at this point in time, we don't have a solution other than Phantom.js, but it is something that we are working on to see if we can come up with a alternative which we ourselves maintain.
Thank you.
Sure. Any other concerns, thoughts? Okay, I think there is a few in chat. I can't. Okay. Will there be a sure? Yeah. Yeah. So yes, you potentially can have a dark theme. But that's something that we can address in the next release. So yeah, sure. Yeah. So Ryan, yes, we can add a dark theme with the next release. Thank you. And hopefully nobody here will get the coronavirus. Any other questions, thoughts, comments, things that you would like to see? And again, I'm trying to make this as interactive as possible, because I'd like to hear feedback from you guys about what you think you would like to see, your comments, your concerns, your questions, instead of just me blabbering on for like 1 hour without giving you guys a chance to come up with your questions, comments, or thoughts.
So maybe I'll throw out just a generic for any site that's interested in looking at this.
Yeah.
What's their best way to engage with the INAM team? Is there a mailing list? What's the right way to plug in with you guys so that they can interact as they try to deploy?
So we have multiple ways. So if you go to the INAM website, which is, let me go back here. So if you go to the INAM website, we have this tool. Sorry. So if you want anything, so we very clearly say here, please email us at this email ID. So I'll ping it in chat as well. So if you want to either deploy INAM or work with us, or if you're having issues with INAM, if you want to see a new feature in INAM, please email us at this email address, mvapitchhelp. We are typically fairly responsive and we get back to you pretty quickly. So feel free to email either me directly or this email alias at the Ohio State University, and we can get back to you. Thank you for bringing that up, Brian. Anything else that you guys would like to see? And you have the DB size calculator here as well. If you want to just get it directly from the INAM deployment, you can do that. So like a few other interesting features, let's say if you want to find a given node, you can try to type the LID and find the node here. So it says that, hey, this particular node is located here on your cluster. So these are like useful features for system administrators, and they can also have like specific names given to switches so that it is easier for them to track what is going on a given system.
All right, well, we're just a minute or two away from the top of the hour.
Okay.
So we'll kind of, Hari's been asking, but if anybody else has any last moment questions, now's the time to kind of bring it up so that we can keep things within the hour.
Sure. Thank you, Janet, and thank you, Jeremy. I'm glad you liked it. So what I would request from all of you guys is this. Feedback is critical for us, and you guys are the end users who hopefully would use it and would like to see this grow and like benefit you guys. So if you have any feedback, good, bad, ugly, please let us know. Negative, we accept criticism in a very positive fashion. If you think something is not as it should be, this is not how like a sysadmin or a user would like to see it, please let us know. Because depending on the kind of hat you are wearing, my perspective might be different from yours. So feedback is always welcome. Thank you.